Imagine a world without curves. A world where the horizon stretches endlessly. A flat plane extending to infinity. This is the world envisioned by flat Earth proponents. A disc-shaped Earth covered by a dome-like sky. At the center lies the North Pole, while the South Pole doesn't exist as a point, replaced by a massive ice wall encircling the outer rim of our world. This ice wall, according to the theory, prevents oceans from cascading off the edge. Above, the sun and moon, much smaller than we perceive, circle above the flat Earth like celestial spotlights, casting their light and warmth upon us. This model of the Earth, while visually compelling, raises numerous questions about the fundamental laws of physics and our understanding of the universe. How would gravity behave? How could day and night occur? What about the changing seasons? These are just a few of the questions we'll explore as we delve into the hypothetical world of a flat Earth. Gravity, the invisible force that holds us to the ground and governs the motion of celestial bodies, poses a significant challenge to the flat Earth model. In our spherical Earth, gravity pulls everything towards the center, explaining why objects fall down and why we experience a similar pull regardless of our location. But on a flat Earth, gravity's behavior would have to be radically different.
One proposed explanation suggests that gravity would pull everything towards the North Pole, the center of the disk. This would lead to some bizarre consequences. For instance, the further you travel from the North Pole, the more horizontal the gravitational pull would become. Walking south would feel like climbing a steeper and steeper hill. Water would flow towards the North Pole, gathering in a massive central ocean, leaving the edges of the world dry and barren. Such a scenario contradicts our everyday experiences and observations, making it clear that gravity, as we understand it, cannot function on a flat Earth.
The flat Earth model proposes that the sun and moon move in circles above the flat Earth, like celestial spotlights. The sun would be closer, illuminating different regions as it moves. However, this fails to account for several observed phenomena.
If the sun were a spotlight, it would be visible from all points on Earth. We wouldn't experience darkness. The sun would just appear smaller.
The flat Earth model also struggles to explain the changing seasons. On a spherical Earth, seasons occur due to the Earth's tilt as it orbits the sun. While the flat Earth model faces significant challenges in explaining fundamental physical laws, it's intriguing to consider whether life could exist on such a world. The answer, simply put, is highly unlikely.
The altered gravity, as proposed by the flat Earth model, would make it difficult for a stable atmosphere to exist. Without a spherical Earth and its gravitational pull, the atmosphere would be free to drift away into space, leaving the planet a barren and lifeless rock. Moreover, the absence of a protective magnetic field, which is generated by the Earth's rotation and protects us from harmful solar radiation, would further diminish the chances of life evolving or surviving on a flat Earth. Without a magnetic field, solar winds would strip away the atmosphere, and intense radiation would bombard the surface, making it hostile to life as we know it.
Section 5, Ancient Beliefs, Modern Doubts, a Historical Perspective.
The belief in a flat Earth is not new. Ancient civilizations, with their limited understanding of the cosmos, often envisioned the Earth as a flat plain covered by a dome-like sky. These beliefs were often intertwined with religious and mythological narratives. For instance, ancient Mesopotamians believed the Earth to be a flat disk, surrounded by a saltwater ocean, with a dome-like firmament above separating the Earth from the heavens. Similarly, ancient Egyptians envisioned the Earth as a flat plain with mountains supporting the sky, and the sun god Ra traveling across the heavens in a boat.
However, as early as ancient Greece, scholars began to observe evidence suggesting the Earth's spherical shape. Aristotle, in the 4th century BC, noted that during lunar eclipses, the Earth's shadow on the moon is always round, which would only be possible if the Earth itself were a sphere. Despite growing scientific evidence supporting a spherical Earth, the flat Earth belief persisted in some cultures and resurfaced periodically throughout history. In modern times, the flat Earth theory has experienced a resurgence fueled by online communities and social media platforms. Section 6. The Edge of the World. What lies beyond the horizon?
One of the most intriguing questions raised by the Flat Earth model is, what lies beyond the edge? Flat Earth proponents offer various explanations, each more imaginative than the last. Some believe the ice wall surrounding the Earth's perimeter acts as an impenetrable barrier, preventing anyone from falling off. Others suggest that the edge is guarded by secret government organizations, tasked with concealing the truth about our flat Earth. Still, others propose that the Earth is infinite, extending endlessly beyond the supposed ice wall. This infinite plane, they argue, could potentially host other unknown lands and civilizations.
These explanations, while entertaining, lack any scientific basis. The idea of an ice wall or a secret government cover-up contradicts our understanding of geography, geology, and international relations. Moreover, the concept of an infinite Earth clashes with the fundamental laws of physics, particularly the law of gravity, which dictates that all objects with mass attract each other. An infinite Earth would possess infinite mass, leading to an infinite gravitational pull that would collapse the entire universe. Section 7. Stars in a flat Earth sky, a different celestial dance.
The flat Earth model struggles to explain the behavior of stars. On a spherical Earth, stars rotate around the celestial poles due to Earth's rotation. This explains different constellations based on location and time of year. On a flat Earth, stars would need to behave differently to create this illusion.
One explanation is stars as points of light on a rotating dome above Earth. However, this fails to account for parallax, the apparent shift in star positions. Section 8. The Moon's new role illuminating a flattened world. The Moon, our celestial neighbor, also poses a challenge to the flat Earth model.
On a spherical Earth, the Moon's phases are explained by the changing angles at which we see the sunlit portion of the Moon as it orbits the Earth.
However, on a flat Earth, the Moon's phases would require a different explanation.
Some flat Earth proponents suggest that the Moon is a self-luminous disk that changes shape.
These explanations lack any scientific basis and fail to account for the observed behavior of the Moon. Section 9. Flat Earth and Physics, a fundamental clash. The flat Earth model, while visually appealing to some, ultimately fails to hold up to scientific scrutiny.
The model contradicts fundamental laws of physics, particularly those governing gravity, motion, and celestial mechanics.
Gravity on a flat Earth would behave very differently from our current understanding.
Gravity would pull everything towards the North Pole, leading to bizarre consequences like water flowing uphill.
The flat Earth model struggles to explain the Coriolis effect, which affects air currents and projectiles.
The Coriolis effect is crucial in weather patterns and navigation, contradicting the flat Earth model.
Section 10. The Power of Observation, Evidence for a Spherical Earth. The evidence for a spherical Earth is overwhelming and comes from a variety of sources, including observations of ships sailing over the horizon. As a ship sails away from the shore, it gradually disappears hull first, followed by the mast, a phenomenon that can only be explained if the Earth is curved. Circumnavigation of the globe. Explorers have circumnavigated the globe, traveling in one direction and returning to their starting point, a feat impossible on a flat Earth. Photographs from space. Numerous photographs taken from space clearly show the Earth's spherical shape. Lunar eclipses. As mentioned earlier, lunar eclipses, where the Earth's shadow is cast on the Moon, always show a circular shadow, regardless of the Earth's orientation, proving that the Earth is a sphere. The changing constellations. The fact that we see different constellations depending on our location and the time of year is only possible if the Earth is a sphere rotating on its axis. These observations, along with countless others, provide irrefutable evidence that the Earth is a sphere, not flat. Section 11. Our Place in the Cosmos. Reflections on a Round World. The realization that the Earth is a sphere was a profound moment in human history. It shifted our understanding of our place in the cosmos, from a central and privileged position to one planet among many, orbiting a star in a vast and ever-expanding universe. Embracing the spherical Earth model allows us to understand and appreciate the natural world around us. It explains the seasons, the tides, the phases of the Moon, and countless other phenomena that shape our lives. Moreover, understanding the Earth's true nature is crucial for addressing global challenges such as climate change, resource management, and international cooperation. By studying the Earth as a complex and interconnected system, we can develop sustainable solutions for the benefit of all humankind. While the flat Earth theory may seem harmless to some, it represents a rejection of scientific evidence and critical thinking. In a world facing increasingly complex challenges, it is more important than ever to embrace scientific literacy and to base our understanding of the world on evidence, not unfounded beliefs.